guys, in this video we are going to talk about the laws of exponents, and we're going to specifically talk about three main ideas in this video. First, what are the laws of exponents? How do we know they work? And then we're going to do some examples so you know how to apply them. Now, there is approximately 7 laws of exponents that we usually see come up as we do problems involving exponents, but in this particular video, I'm only going to address 3 of them, and make sure you look out for the link in the description box when I post the video that explains the other 4 laws of exponents. So let's get started. The first law is going to be multiplication with the same base. And this law, in its general form, looks something like x to the power of n multiplied by x to the power of m is equal to x to the power of n plus m. So that's the general representation of this law. So what does that mean? That means that if I have the same base raised to a power, it doesn't matter what the power is, and I multiply those two, then it should be the same as if I simply had the same base and I added the powers. I should get the same answer. So in other words, let's first of all use different indices, which is pretty much talking about the n and the m in our expression here. So if I change the n and the m to numbers, it will be x to the power of 3 multiplied by x to the power of 2 is equal. It should be equal to x to the power of 3 plus 2, which is equal to x to the power of 5. And that's pretty much what it's saying. And it doesn't matter if it's an x, it can be a y, but the bases in this case have to be the same. In other words, I can't say y squared multiplied by z squared is equal to somehow y 2 plus 2 or 3 plus 2. That doesn't work. The bases have to be the same in order for this law to apply here. Now, how do we know this works? Well, you simply use a different, or you simply, instead of using x's as your base, let's go ahead and plug in actual numbers. Let's say we use base 10. So for every x, I'm going to just substitute it with a 10. So 10 cubed multiplied by 10 squared. It should be the same as 10 to the power of 3 plus 2, which is the same as 10 to the power of 5. And 10 to the power of 5 is going to be 100,000. So now let's break this down and see if it actually is true. 10 cubed is 1,000 multiplied by 10 squared, which is simply 100. So the question is this actually equal to 100,000? Well, when you put this in your calculator, it absolutely is. And we know that that's the same as 10 to the power of 5. So basically, what we notice here is that the law is simply just a shortcut, or memorizing the law is a shortcut to being able to do this kind of math. And it really does help to make things a little bit quicker. And so let's go ahead now and look at another law. Our second law is division with same base. And the general form is x to the power of n divided by x to the power of n should be equal to, or can be rewritten as, x to the power of n minus m. Now notice that the n, which is the power of our numerator, is what is subtracting the power of our denominator, okay? So the order does matter here. So if we were to change n and m into numbers, then we'll have something like this. X to the power of 4 divided by x to the power of 2 can be rewritten as x to the power of 4 minus 2. Let's change that. 4 minus 2, which should be x squared. Now, let's go ahead now and see, why do we know this to be true? How do we know this works? Well, in this case, we're simply going to substitute our x's for numbers. You can choose any number you wish, but just remember that the bases have to be the same. So in this case, I'm going to let our base be 2. So 2 to the power of 4 divided by 2 squared is equal to, and based on our law, it says it should be equal to this base to the power of 4 minus 2, which is the same thing as 2 squared, which simplifies to being 4. Now what we're going to do is we're going to go the long way and see if 2 to the power 4 divided by 2 squared is actually equal to 4, what we should arrive at. So 2 to the power of 4 is going to be 16. And then you have 2 squared, which is 4. And so 16 divided by 4 is going to be 4. So therefore, we arrive at the same answers. Okay? Next, we have the zero power rule. And this rule is one that I really like because it's very quick at simplifying expressions or equations when you identify it. So what this rule says is anything to the power of 0, in this case x to the power of 0, is equal to 1. So if I have y to the power of 0, that's also equal to 1. Or if I have a number to the power of 0, let's say the number 10 to the power of 0, it's going to be equal to 1 as well. So now the question is, how do I know this is true, or how do people arrive at this? And right now, what you want to note is that it's really a matter of relationship and an equivalent relationship specifically. So consider this for a moment. If I have 10 divided by 10, I know that this is going to be equal to 1, right? Well, consider x divided by x. Typically, if you see this in an equation, you're going to simplify this as equal to 1. Now, let's apply x over x. Let's apply, instead of just our common knowledge, let's go ahead and apply the previous rule we just learned. We know that if the base is the same and we're dividing, then this is the same as saying you could use the base raised to the power of the numerator, which is 1, minus the power of the denominator, which is also 1. And so this simplifies to x to the power of 1 minus 1, which is 0. So if you notice that there's an equivalent relationship, what does that mean? So we know that 1 is the same as x over x, which we know can simplify to x to the power of 1 minus 1, which ends up being x to the power of 0. So using a transitive property, if 1 is equal to another, which is equal to something else, then you can make the relationship from the beginning to the end as well. So in other words, if 1 is equal to this, and this is equal to x to the power of 0, then the transitive property said then this has to be equal as well. And so that's pretty much the understanding or the explanation of the zero power rule. Make sure you stay tuned for the next video that's going to explain to you the other 4 rules of exponents.